Alright, welcome back. In the previous video we worked this problem and we determined the rate constant assuming the reaction was first order in A. So let's read the problem again, and this is using integrated rate laws to determine quantities. A novel reaction of unknown reaction order involves one reactant A whose concentration declines from 0.6 molar to 0.2 molar in 45 seconds. Now in the previous video we determined the rate constant assuming it was a first order reaction, and we got 0.0244 per second. Now what we want to do is we want to calculate the rate constant assuming it's second order. So for that we're going to have to use a different rate law. It's going to be the second order integrated rate law, and it looks like this. Alright, so it's going to be 1 over the concentration of A sub t is equal to 1 over the concentration of A naught, the initial concentration, plus K times T. Alright, so this is going to be it. Alright, so let's go ahead and plug numbers in. Now what was our A sub T? That was 0.2. That's our final concentration at 45 seconds, so 0.2. So this is going to be 1 divided by 0.200 is equal to 1 divided by our initial concentration is 0.600, and that's plus K times 45 seconds. All right, so let's go ahead and figure this out. 1 divided by 0.2 is 5. Okay, so this is 5. We're going to subtract this fraction over here. So it's going to be minus, what is 1 divided by 0.6? Turns out it's 1.66 repeating, or 1.67. And that's equal to K times 45 seconds. So we're going to do 5 minus that, 5 minus 1.666 repeating, on, and we get about 3.33 is equal to K times 45. So now we're going to divide both sides by 45 and get the magnitude of the second order rate constant. All right, and it turns out that our magnitude is going to be, so K, second order, is 3.33 divided by 45. And this rate constant is about 0.0741. And we need to figure out the units of a second order rate constant. Now you could just memorize them, but if you were curious where it comes from, we're going to do something that we did in the previous video. Let's write a generic second order rate law. The rate R is equal to the rate constant times any second order reaction. I'll usually just do A squared. You could do A times B, although this reaction is going to be A squared. This is the rate law for the reaction. But I just need to where the overall reaction order is 2, second order. And what I'm going to do is I'm going to fill in the units of each of these variables. Rate is always molar per second, or some concentration per unit time. We're solving for the units of K, and then what is concentration's unit? Well, it's molar. So if we have concentration squared, then this has to be molar squared. This is going to be molar squared. So now what I'm going to do is I'm going to divide both sides by molar squared. Notice this side completely goes away, and so the units for K2, a second order rate constant, are going to have to be molar divided by molar squared, which is 1 over molar, and then over seconds. So this is going to be inverse molar inverse seconds. And those have to be the units for a second order rate constant. So when I report this rate constant, it's going to be for second order inverse molar inverse seconds. All right, and that's going to be my answer for this. All right, so what I want to do is I'm going to bring this back up here. All right, now we see those rate constants are different, and that's because we assume they're different reaction orders. All right, so that's how you do the same thing using integrated rate law, assuming it's a second order reaction. So pretty much all you do is you just look at the problem, and it'll tell you which equation to use, first or second order, in some way, and you just pick that equation and plug numbers in and solve for the variable that you don't know, the one that it's asking for. All right? Now this last one right here, we're going to do in another video, and this is where we're going to determine if it's truly first or second order given other data. All right, so join us in the next video where we show how to predict which mechanism it actually is. All right, make sure to like this video and subscribe to the channel for future videos and notifications. Thank you.